Okay, I'm Jonathan Doolin. I'm continuing to read Planetary Core and Surface Temperatures, give my reaction to it. It's a paper by Douglas J. Cotton, published in 2013 in a magazine called the SSRN Electronic Journal. In my second video, I went through paragraphs 1 and 2 of section 2, and I had a lot to say about it, which ended up taking about 20 minutes. There's one big difference in my opinion versus the opinion of the author of this paper. He claimed that oxygen and nitrogen were good insulators, and I suggested that maybe oxygen and nitrogen weren't very good insulators because neither of them stop radiation, neither of them stop conduction, and neither of them stop convection. And so I said that actually they were worse insulators than, for instance, carbon dioxide, which is a better insulator than any diatomic gas. At this point, though, I think it is important to try to figure out exactly what his model looks like, because he's saying let's acknowledge that he has claimed that nitrogen and oxygen are insulators and carbon dioxide and water vapor are radiators. So I don't know, I don't know exactly what his model looks like, but I'm going to try to reproduce it to the best of my ability. Just kind of starting with this model that I've drawn earlier as a template. What this model has the surface of the Earth at 14 degrees Celsius, the outer atmosphere of the Earth at minus 19 degrees Celsius, and this insulative layer of atmosphere in between. So what I'm going to try to do is try to describe his, where, yeah, it's basically trace amounts of carbon dioxide in this model that create the insulative effect. But he's saying it's not the carbon dioxide that is the insulator, but it is, I guess maybe it would look identical. Maybe the description is just identical, except that instead of carbon dioxide being the insulator, it is the oxygen and nitrogen which is the insulator. And carbon dioxide, which contributes to the radiation. It's not. No, it's there's too many moving parts. Okay, is this how he's picturing it? Okay, we've got the carbon dioxide kind of at the bottom, and it is radiating heat away from the planet, while the oxygen and nitrogen are insulating the planet. Or, okay, could it be like this? Is he imagining the oxygen and nitrogen on the inside, insulating the planet, and then surrounded by this layer of carbon dioxide gas that is radiating heat away from the planet? Or, okay, option 3, so O2, N2, and CO2 mixed. I think this is maybe more likely what he's thinking of, that the oxygen and nitrogen are both insulating the planet, while the CO2 is doing its darndest to radiate heat away from the planet, but the O2 and N2 are capturing it. Okay, so I think this has got to be it. This is the only one that makes sense. That his point of view on the topic, he's saying that the oxygen and nitrogen are both insulating the Earth, while the carbon dioxide is doing its damnedest to radiate heat away from the planet. And if the carbon dioxide were not there, then maybe the temperature of the Earth would be even greater, because the oxygen and nitrogen would have that insulating effect that would prevent heat from getting away from the planet. I don't know. That seems to be. I'll read that a little bit more to just confirm whether I think that's what he thinks is the situation. On the other hand, this is what I think is going on. The oxygen and nitrogen are both completely transparent, so they essentially have no effect of insulation they have no insulative effect on the planet at all, while carbon dioxide and methane and other non-diatomic gases have both an insulating effect and a radiating effect. They insulate um, all the way up to the outermost layer, and then they radiate at the top. That is the way I would view it. They have both an insulative and radiating effect. So let's read this and see if I've got the right idea of what his view is. Since it is indeed correct to say that radiation from the atmosphere does slow the component of surface cooling, which is itself by radiation. I'm like, okay, syntax error, cannot parse. I think it's saying that the radiation from the atmosphere goes downward towards the surface, which so that would some of the radiation from the atmosphere does go downward towards the surface, which slows the cooling. And he says, but at the same time, the presence of all air molecules just above the surface will also have a somewhat greater effect, slowing the cooling of the surface. Okay, I think what he's just making a distinction of here is the molecules just above the surface versus molecules from elsewhere in the atmosphere. So he's saying that the molecules in this region have maybe a greater effect on the on keeping the surface warm than atoms in this area. Maybe that's what it is. So I think he's reasoning through something that I described earlier with a cold and warm part of a blanket, saying that, but the warm side, the bottom part of a blanket, has more of an effect. Slows the cooling of the body less than the cold part of the blanket. So I think, whoops. Okay, I think that's a pretty good question to ask. Does the cold part of the blanket actually have less influence over the warmth of the body than the warm part of the blanket? And I think the warm part of the blanket will definitely be closer to the temperature of the body, but both surfaces will have the same essential principle that heat in is equal to heat out. Okay, so I think what I'm going to do, in the interest of figuring out what this paragraph is actually saying, I'm going to do ungodly, horrible things to it. And I apologize to the author, but what I'm going to do is try to just try to create an analogy with something that I can understand, so that maybe I can kind of figure out, parse out the words. It is indeed correct that conduction from the and I'm going to say blanket here, does slow the component of body cooling, which is itself by conduction. But at the same time, the presence of all the portion of blanket, the lower surface of the blanket, the lower surface of the blanket will also have a somewhat greater effect of slowing the cooling of the body. Okay. Okay, molecules of a gas move around freely between impacts with others, and energy is transferred into these molecules as they collide with the surface. And I'm pretty sure by surface we're talking about the lower surface. The body. Okay, and the body, and this, let's be clear, instead of calling this conduction, let's call it conduction 2, and which is itself by conduction 2. And the reason I want to call it conduction 2 is because I have these two different versions of conduction. Version 1 is molecules transferring heat by colliding with each other, and 2 is failed radiation, a photon going a very short distance. So it's indeed correct to say that by failed radiation from the blanket does slow the component of body cooling, which is itself by failed radiation. But at the same time, the presence of the lower surface at the blanket will have somewhat greater effect. The presence of, and I'd say the proximity of the blanket with the body means also a somewhat greater effect slowing the cooling of the body. Molecules of gas move between, and this is in conduction 1, which is the other version of conduction, molecules transferring heat by colliding with each other. Molecules of gas move around freely between impacts with others, and energy is transferred into these molecules as they collide with the body. So ordinary nitrogen and oxygen molecules also have an insulating role. Okay, I'm going to stop here because, okay, this is, if I haven't been totally misinterpreting things, this is weird. Why? Because he's just described conduction 1. Molecules of gas move around freely between impacts with others. Energy is transferred into these molecules as they collide with the body. This is a description of conduction, which is not a description of insulation, but it is followed with so ordinary nitrogen and oxygen molecules also have an insulating role, which I would interpret as it follows that nitrogen and oxygen molecules also have an insulating role. So let's make a table, because I'm kind of confusing myself here. O2 and N2. When I come up to, let's say I come up to the oven and I am getting ready to pull out a pan full of cookies, am I concerned about the heat passing through oxygen and nitrogen? I am not. I am not concerned about the heat passing through the oxygen and nitrogen. So I'm going to say that yes, oxygen and nitrogen are conductive insulators. As far as whether they are oxygen and whether they are radiative insulators, though. If I have an infrared light, do I expect them to do any better than a vacuum in providing radiative insulation? No. So I would say that as far as radiative insulator goes, they are definitely not radiative insulators. Carbon dioxide, yes. Yes, it is a radiative insulator in the infrared. Conductive insulator, I really don't know. It's such a maybe. I'll call it maybe. But that means I have to come back and revisit this table here and think once more, because you remember I kind of read that answer off the internet. And do oxygen and nitrogen actually stop conduction? And I'm gonna actually change these answers. I'm gonna change this to yes, yes, and maybe, because when I walk up to the oven and I am pulling that pan out of the oven, I have no fear of burning my hand until I actually touch the pan. And I have no fear of oxygen and nitrogen conveying that heat to my hand. Well, maybe a little bit. but not near as much as a direct contact is. So yeah, oxygen and nitrogen definitely do stop conduction far more than direct contact does. So here, in conduction 1, molecules of a gas move around freely between impacts with others, and energy is transferred into these molecules as they collide with the body. And that is not done by nitrogen and oxygen. So, or not very much. It's not done by nitrogen and oxygen very much. So, those molecules, so it should actually be by contrast. Ordinary nitrogen and oxygen molecules have an insulating role because they do not transfer very much heat in this way. Okay, so he continues, and the closer the temperatures get between the surface and these air molecules, and the closer the temperatures get between the surface and these air molecules, the more they will slow the cooling process. Wait a second. Does that make any sense? Okay, the way I'm thinking of this, and I'm not sure, but the way, to me, the insulative effect of the oxygen and nitrogen um, is only based on conduction. It's not based on radiation, because oxygen and nitrogen are not going to stop radiation at all. But insofar as they are insulators, then the way they stop conduction is that basically you're not making any kind of contact with the substance. So um, you would also not be making contact with the substance if you put a vacuum between you and the substance. So the way oxygen and nitrogen are insulators in this case is similar to the same way that a vacuum would be an insulator. So when he says the closer the temperatures get between the surface and these air molecules, the more they will slow the cooling process. That doesn't sound right to me, because it's not a matter of them being close. It's a matter of them acting pretty much having the conductive insulation, same in conductive insulation as a vacuum. So they need not be any closer to the surface, and their insulating ability is not improved by bringing them closer to the surface. And they're not a real blanket either, because the insulative effect that you're talking about is the conductive insulation that a vacuum has. So here where it says they are the real blanket for the very reason that they do not radiate much at typical temperatures found in the troposphere, I would say oxygen and nitrogen do not radiate at all. They have essentially the same conductive properties as a vacuum. That is near perfect conductive insulation, and near perfect radiative transparency. So they're perfect transmitters of radiation and perfect insulators of conduction, of heat conduction. So says there the real blanket. So instead it is the water vapor and other radiating molecules like carbon dioxide which radiate out of the atmosphere and thus act like holes in the blanket. Holes in the blanket. Yeah, I think he's a little bit confused, because so let's just kind of summarize that. Oxygen and nitrogen, the diatomic molecules, and I would probably put H2 in this category as well. H2. There are near perfect radiative transmitters. Which means that any color of light can go right through them without being stopped at all. And they're also near perfect conductive insulators, which means that if there's a hot pan of fried chicken and you can bring your hand as close as you want to that pan, as long as you don't touch it, your hand isn't going to burn. But as soon as you touch it, then you're going to feel a lot of heat coming through. But what else has these properties of being near perfect radiative transmitter and near perfect conductive insulators? The vacuum of space has this same property. So H2, O2, N2 are transparent, and the heat doesn't conduct through them, just like the vacuum of space. Now that means that by analogy, if you actually surround the Earth with an atmosphere of just pure oxygen and nitrogen, what would happen is though the ground was exposed to a pure vacuum of space. I mean, it wouldn't be quite the same because, I mean, you'd have oxygen and nitrogen in there, so there'd be a gas that maybe you could breathe, but instead of this minus 19 degrees Celsius being out here, exposed to the pure vacuum of space, you'd have that minus 19 degrees Celsius all the way down here, where because of greenhouse gases, there's a big difference between those two temperatures, and we can survive down here quite nicely.